In this lesson, you will learn how to assign oxidation numbers to atoms and ions in a substance. The first rule for assigning oxidation numbers is that a pure element has an oxidation number of 0. This includes the atoms that are part of a diatomic element. For some reason, many people forget this rule, so make sure you always remember to check this first. So if we look at the first two symbols here, we have Cl. Cl is written as a pure element by itself, one atom, so this would have an oxidation number of 0. Cl2, it's a diatomic. It is still a pure element, so each chlorine here would still have an oxidation number of 0. However, the last one is not written as a pure element. It has a negative charge on it. So this is actually a monoatomic ion, and a monoatomic ion has an oxidation number identical to its charge. So chlorine with nothing written next to it has a charge of 0. However, if chlorine is written with a negative charge, then the oxidation number is 0. Oxidation numbers are kind of like charges, but not exactly. However, in the case of ions, the oxidation number is the charge. Metals from group 1 have an oxidation number of +1, since they form ions with a positive 1 charge. Notice I did point out that these are metals in group 1, not just elements in group 1, because hydrogen is in group 1, but it's not always going to be positive 1. Elements from group 2 have an oxidation number of positive 2. They always form ions with a positive 2 charge. Hydrogen does usually have a charge of positive 1, or an oxidation number of positive 1. However, if it's combined with a metal, the metal has to have a positive charge because metals lose electrons when they form ions. So, since the metal has to be a positive charge, the hydrogen is then forced to be -1. So hydrogen will usually be positive 1, unless being combined with a metal, it is forced to be -1. Oxygen has an oxidation number of -2, usually. The only exception to that will be when it is combined with an element from group 1 in a 2:2 ratio, for example, H2O2, hydrogen peroxide. In this case, the hydrogen has to be positive 1, and in that case, the oxygen is forced to have a -1 oxidation number. And that's because it's not there as an oxygen ion, it's actually part of a polyatomic ion. So this is a rare exception that we'll deal with a few times, but for the most part, oxygen will be -2. Number 7 is where most of the work comes into play. All of the other rules tell you if it's this element, it has this charge. This rule tells us that if we add up the oxidation numbers of all of the atoms in a compound, it must add up to 0. If I have a polyatomic ion, when I add up all of the oxidation numbers for those atoms, it needs to add up to the charge of the polyatomic ion. Now, one thing to keep in mind is all of the possible oxidation numbers are written on your reference table in that upper right-hand corner. So you can always use the periodic table to help you figure out what some of the charges are. If you get an answer that is not one of those numbers listed on the periodic table, for my class at least, you've done it wrong. I have verified that all of them are ones that are actually written there. However, if you look at the periodic table, it does say selected oxidation states, which means New York State might have left some off. All right, so let's start with K2CR2O7. If we go through the rules, we don't have a pure element there. But we do have something in group 1. Potassium is a group 1 metal. And I know that group 1 metals have to have a charge of +1. I also have oxygen, It's not in a 2-to-2 ratio with something from group 1, so the oxygen has to have a charge of -2. Now, I still need to determine what the oxidation number of chromium is, so I'm going to call that X. Now, when I say that they have to add up to 0, I need to take into account the number of each atom of each type. So I can set this up as an algebraic equation. If you want to do this in your head, as long as you can do the algebra, that's fine. But I have 2 potassiums. Each potassium has a charge of +1. Plus 2 chromiums with a charge of X, plus 7 oxygens with a charge of -2. So when I add all of those up together, taking into account the number of each type, they have to add up to 0. So if I distribute or multiply through and then combine like terms, I end up with X is equal to a +6 charge. So now I can take out the X for chromium, and I know that the chromium itself, each chromium, is going to have a charge of +6. Notice you are always going to be writing the charge for one atom of that particular element. Next we have NO3 -2, which is a polyatomic ion. So I know that oxygen has to have a -2 charge. I don't know what nitrogen is. If I write that out in algebraic form, I have nitrogen, X, plus 3 oxygens, each with a -2 charge. In this case, it tells me it's a polyatomic ion with a charge of -2, so those have to add up to -2. So if I solve that, I have X minus 6 equals -2. So X has to equal +4. So now I can take the X out, and I know that nitrogen has a charge of +4. So again, when you're assigning the oxidation numbers, go through the rules in order. There are several that we know exactly what those oxidation numbers have to be, but there are several with exceptions. Use number 7, figure out what you already know, and solve for what you don't know. And again, check your answer on the periodic table when you're done to verify that you got a possible answer.